Welcome to Pomodoro Joe for Wednesday, July 12th, 2023. Today we're doing LeetCode problem 802, find eventual safe states. This is a medium problem. All right, there is a directed graph of n nodes, with each node labeled from 0 to n minus 1. The graph is represented by a zero-indexed 2D integer array graph, where graph index I is an integer array of nodes adjacent to graph node I, meaning there is an edge from node I to each node in graph index I. All right, what that's saying is we have this list, and each element in the list represents a node, and the value in that list is another list of nodes that that node is connected to. So these are the edges. So this 1 and 2. So our 0 node is connected to 1 and 2. All right. A node is a terminal node if there are no outgoing edges. For example, node 6 or node 4. A node is a safe node if every possible path starting from that node leads to a terminal node or another safe node. Return an array containing all the safe nodes of the graph. The answer should be sorted in ascending order. All right, then we have our example here. So they have 0, 1, 2, 3, 4, 5, 6. These are our nodes. And from node 0, we can go to 1, we can go to 2, we can go to 3. So, is that right? No, just 1 and 2. Oh, I see. 3 can go to 0. Try this again. So, 0 can go to 1 or 2. Now, these are not terminal nodes. So then we look at node 1. That can go to 2 or 3. Again, these are not terminal nodes, so we have to go on. Node 2 can go to 5. All right, so then we have to look at 3. Oh, 3, it looks like can go to 0, 1, 2, 3, 0. So 3 can go back to 0. Oh, so that means we have a cycle. We have 0 going from, let's see, 0 to 1, and then 1 to 3, and then back to 0. So 0 is not a safe node. All right, 2 though, it looks like 2 goes to 5, and 5, 0, 1, 2, 3, 4, 5, is a terminal node. So 2 could be a safe node, right? 0, 1, 2. 2 only goes to 5, so that's a terminal node. 2 should be safe. All right, so in the end here, it looks like we have 2, 4, 5, 6. I'm not going to go through all of them, but that's our basics. All right, then we have some constraints. Okay, so let's put 25 minutes on our Pomodoro timer, and we will get started. This one's going to be a bit tricky, but I think we can break this down into steps and make it easier on ourselves. So we'll start with our result here. That's going to be some list, because we know we have to return a list of all of our safe nodes. And then we can return our result. All right. So the next step, we know that we need to return all of our results in a sorted order. So I think what I'll do is just go through every node in our graph, just from start to finish, 0, 1, 2, 3, 4, 5, 6. Just check to see if it's a safe node. If it is, I'll put it in the result, and we can move on. So we'll have some for loop here. So for every node in graph, well, let's see, I don't want to do that. I actually want the node name here. So that's the index of the graph. So that's going to be range length of graph. All right, so for every node in the range length graph, let's just have some function. We'll just make this up. So if is safe node, we'll pass in our node. And if it is a safe node, then we'll put it in our result. We'll just append our node. Cool. So we're going to go through every node in our graph. If it's a safe node, we're going to put it into our result array. And then we return our result array. Yeah, so we're done, right? No, okay, I wish. So we still have to create this isSafeNode function. So how do we determine if something is a safe node? And of course, my paste doesn't work again. All right. All right, so isSafeNode, this will take some node. And at this point, we'll return true or false, whether or not this is a safe node. Okay, so how do we determine if something is a safe node? Let's break this down. So this will be probably a recursive function, because what we need to do is look at this node and all the nodes it's connected to. So if this node is a safe node, we can return true. If this node is not a safe node, or if we don't know if it's a safe node, then we have to look at all the nodes that it's connected to. If all the nodes that it's connected to are safe nodes, then we can return true. If one of the nodes that it's connected to is not a safe node, then we have to return false. So let's break this down into the steps that we kind of know. We kind of know we have to go through all the connected nodes to see if those are safe nodes. So let's do this. All right, so the connected nodes are the graph for this node. Then for every connected node in our connected nodes, we'll check to see if that node is a safe node. All right. So we can either check to see if it's a safe node and keep track of whether or not they're all safe, or we can just find one that's not safe and we'll return false at that point. So let's just check if this is not a safe node. So if this node is not a safe node, then we will return false. Otherwise, if we make it through all the connected nodes and they all are safe nodes, then we can return true. Okay, so this is looking kind of good. We have our framework. Of course, this won't work yet because this function isn't really complete. This is a recursive function and it doesn't have a base case. So we do need some base case here. Well, this is very similar to a graph traversal. If we go through these nodes, we might need to keep track of which nodes we've already visited. So let's do that. Let's have some visited out here. Have some set. All right, so if this node is already visited, then we'll have to return false because that means we have a cycle. Otherwise, we'll add the node to visited. Then we'll get the connected nodes. We'll go through checking if they're safe nodes. All right, and we return false if one of them's not safe. And it's not safe if we've already visited it before. Okay. Let's see, now will this work with our terminal node? I think it does. So if we come into our terminal node, it's not going to be visited yet, but the connected nodes will be empty, so we won't go through this loop and we'll just return true. All right, so this does work with our terminal node. All right, so let's just do an example. We go from 0 to 1. So we put 1 in, we put 0 in visited, then we put 1 in visited. Then we go from 1 to 2, and we put 2 in visited. Then we go from 2 to 5. We put 5 in visited, and we're done. Then in our loop down here, we move on to node 1. Or let's say we get to node 2. We'll move on to node 1, and then we'll move to node 2. When we do this check on node 2, we'll come in here is safe. Node 2 was visited because we went from node 0 to node 2, which means that this will return false when we're just checking node 2 for the first time. So we actually need to clear out our is visited every single time we go through this loop. So we'd have to do something like this. So create a new set every time. Oh man, that's really ugly. Or we'd have to pass in our set. Maybe we'd have to pass in visited here, something like that. Yeah, that's really ugly. Not really a fan of that. Well, we could try it. Let's just try this. So we have visited, we'll start it as none. We'll create our visited in here. Then we'll come through, do this add. All right, let's just separate these a little bit. All right, so will this work? I'm not really sure. Let's give it a try. That works. All right, will this pass all of our tests? Let's check it out. Oh, but we get a wrong answer. So what's going on here? Looks like we have 0, 2, 3, 4 when we should have 0, 1, 2, 3, 4. Let's use this test case. All right, the problem with this one is we go from 0, 1, so this is node 1. We go node 1 to 2. It goes to 3, goes to 4. That returns true because 4 is a terminal node. But then when we go to 3, we'll jump to 3. Oh, we've already seen 3, so it's in our visited, so we're going to return false. We're not keeping track of our result for 3. So this is what we need to do. We need to memoize or use some dynamic programming to keep track of our results. All right, so this doesn't work. And the main reason why this doesn't work is because when we go from one node to another node, we'll put that node in visited. If for some reason we loop back on that same node again, at this point it's a false. We have to return that we have a loop. We have a cycle. However, if we go through every connected node, and some of those connected nodes go through the same node along the way to the terminal node, then at that point we'll return false because that node is invisited, even though it is a safe node itself. So what we really need to do is keep track of which nodes in our path are safe nodes. So for that, we'll use some dynamic programming or memoization. I'll use DP, we'll use a dictionary. All right, so then in here, we can just say, if we have some value for this DP, so if node is in our DP, then we'll just return DP for this node. All right, so that means we've already been to this node and determined whether or not it is safe, and then we can just return that value. Otherwise, if the node is invisited, well then we need to set our DP here for this node equal to false. So anywhere that we have a return value, we'll just have to set it in our DP. Same thing here, DP for our node equals false, and then also down here, DP for our node is equal to true. Okay, so that means the first time we come through, if we have a shared node, we might set it to false in here. Let's see. No, if it's in visited, so we'll just add it to visited, but we'll still make it out this end. So then we'll set it to true, and then we should early out here so we don't even get to this check for visited. All right, so let's see if this passes our one test case that we're not currently passing. And it does. Okay, got it. Let's try this with all the test cases. And we pass. And we do okay. We only beat 23% for runtime and 65% for memory. So let's jump back and let's clean this up. So one thing we're doing is we have visited here, and we have to clear out visited every single time and have a new visited. That's expensive, not only in memory, but in runtime to keep creating these and clearing them out. So what if we got rid of this visited? We don't really seem to need this visited because we're setting this here, but we could just check to see if we have a value in our DP. So our DP can actually take the place of our visited. We don't need both of these things. So let's get rid of visited here. So we're getting rid of visited, get rid of our visited. All right, now if the node is in DP, then we'll return the value. Now if the node is in visited, well, if it's in visited, it's already in our DP. Okay, we've determined that because we'll return something if we've already visited this node, and we'll store that value in the DP. So this should never happen. If we get to here, it's already not in visited. So we can get rid of all of this. Okay, but as soon as we enter this function, we do need to set some value for our DP. Okay, so our DP, if we don't have a value yet, then we need to give it some default value. So we'll set the DP of our node to false. So the way this works is instead of having our visited, we just have DP for this node. If this node is not in the DP, that means we haven't visited this node yet. We haven't checked to see if it's safe. We'll just set it to false by default. So if it ever comes back in here, it will have this set value and it will return false. That means we have a cycle. If we make all these recursive calls down here and we don't run into the same node again, we won't run into calling this DP. So we'll reset this DP to true here. So this gets rid of our visited set, which actually should make this a little bit faster. Let's give it a try. Still works. Let's see if it can beat our previous runtime. And we do. Now we're at 52% for runtime and 75% for memory. So that's much better. Now I'll go through, we only have 4 minutes, but I'll go through this really quick. One thing we can do here, we already know how many nodes we have in our graph. So we can just make this a list, set it to none. Let's see, we'll need n. Well, let's just do it this way. So we'll make this a list of all none values for the length of our graph. So instead of having node in DP, we'll have to say if DP at this node is not none. All right, so if the DP for this node isn't none, that means we've set it. We can return that value. Otherwise it's none, we'll set it to false, do all this stuff. Everything else is the same. So this might save us a little bit because instead of using a dictionary, we're just using a set array. And that gets us to a 99.32% for runtime and a 91% for memory. That is huge. I think that's one of the best scores I've ever gotten. So 99% for runtime and 91% for memory. That is awesome. Okay, I think that is it for me. Again, check this one out. This is LeetCode problem 802, find eventual safe states. Okay. Well, I hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.